All right, welcome to Wise Up on Air. I'm Damian Kaspar, I'm product manager here at Audiokinetic, and I'm joined by Bernard Rodrigue. Hey, Bernard.
Hello.
Good to see you today. Thanks for joining us for this exciting hands-on edition of Wise Up on Air with the Wwise Authoring API and Wwise Authoring Query Language. Whew. Now that we've said it out loud, we're going to refer to those as WAAPI and WAQL. The kind of side effect of this feature is that it's got a cool acronym that you can say fast. So yeah, nice work on that. And Bernard, introduce yourself for folks out there. Let them know what you get up to here at Audiokinetic.
Yeah, so I'm Bernard Rodrigue. I'm a Director, Wwise Experience. I've been with Audiokinetic for the last 18 years, and I've been involved mostly on Wwise Authoring and a lot of features, worked on a lot of features in the past years. And one of the features is WAAPI, which I think we introduced in 2017, and since then it's been evolving. And today we have something new to present.
Cool.
Yeah.
And what would you say the short description of what WAAPI, WAPL, and Wiki? No, hold on. Short description of WAAPI and WAQL.
Yeah. So let's take a few minutes to introduce WAAPI. So anyone that is not aware of what's doing. So you see my screen.
Great.
So,
yep.
Well, let's take a look at what we will talk today, and then we'll talk about WAAPI just after. So today, we'll present WAAPI quickly, overview of WAAPI, what it is for, and where to start with WAAPI. We'll have a few words about what's new in 22.1. In particular, we'll have a demo of a new function in WAAPI for 22.1. It's called object.set. We'll have a live demo for that. And then we'll go through the GitHub repo. And I have a project in which there's 6 different samples, and we'll go through a few samples that we presented a couple of years ago at the previous Wise Up on Air. And we also will see 3 new samples about different things.
Awesome. Well, I'll get a link to that previous live stream into the chat here as you get started. And folks who are joining in, feel free to let us know if you've already had your hands on WAAPI and WAQL, what kind of things you've been doing to extend your workflows using those tools. Happy to carry those ideas to the live stream. And yeah, good to see some folks out there joining in. So let us know if you have questions along the way, and take it away, Bernard.
Yeah, so let's talk a bit about WAAPI. So WAAPI is a framework to communicate with Wwise Authoring. It's an API. So the word API is in WAAPI, Wwise Authoring API. And so we have a list of functions that you can call from an external application to Wwise, and then get results. So in WAAPI, there's a remote procedure called system, allows you to call function and get results. And it is also a system in which you can subscribe to a topic and be notified whenever something happens in Wwise Authoring. And so on the client side, WAAPI can be implemented. Clients can use JavaScript, Python, C#, and C++ to implement their WAAPI code. And on the Wwise side, which we call the server here, well, you have access to user interface, business logic, and the entire project, and also the sound engine, which is part of Wwise Authoring. Well, let's go through a few things that you can do with WAAPI. So as I mentioned, we can access the entire data model, but we don't need to go through the XML files of the work unit. We can directly ask WAAPI, maybe using WAQL, to get objects on the project. We can also create objects, set the different things on objects, and that we'll talk more about today. We also have access to the sound bank system, importing new audio file. We can play objects, same as the transport, for example. And we have also access to high-level stuff, such as user interface, controlling views, getting selection from the views, inspecting object. And lastly, we have access to most of the Sound Engine API that is also available in C++ in a game. This is also available directly in WAAPI. So creating game objects, setting positions on those objects, posting events are things that you can do with WAAPI through Wwise Authoring. So maybe another few words about where to start. So if you don't know where to start with WAAPI, it's pretty easy to get started. You pick your language, programming language, and then you get the client from the website. So the documentation website on audiokinetic.com has all the different example of all the different languages. There's a sample you can start with. So you just copy paste the code and start with that. And then you run the sample and it works. And we will do that today. And we will be using Python today for the examples. Okay, so shall we talk about what's new in 22.1? So there's a long list of new functions in 22.1. I won't read them all, but so there's stuff about setting objects, also new functions about the base property features and profiler, also new profiler functions, and more. So take a look at the release notes. Everything is there, and you can actually click the different functions to know what they do. Today we'll talk more about object.set, which is the first one in this list. Object.set is a new function. In earlier versions of Wwise, if you wanted to set things on different objects, you had to use, for example, set name, set node, set property, set reference, and create. And object.set, it replaces all these functions. And we can do all these things together in the same function at the same time. And we'll have a few examples of that. And one other feature of the object.set, it allows for batch operation. Also allows for creating RTPC, which is a new thing in WAAPI 22.1. Creating effects plugin and creating source plugins is also new in 22. And this is done through object.set. And object.set also will have new features for next release of Wwise 23. They're already being worked on by the team, and more to come. So I think we're ready for a demo.
That's great. And one of the things I just want to highlight there is how cool it is that as WAAPI has released that over the years you continue to expand the functionality, and a lot of the way that has evolved has been informed by what folks out there in the community are using WAAPI and WAQL for in their pipelines. So great again to see how that continues to be informed and grow to be a tool that people can use to extend their pipeline. So nice work.
Mm-hmm. Okay, so let's go. So what I have here is VS Code, and also I have Wwise on the side. and I already created the empty file. It's a Python file. It's empty at the moment. So if you're using Python, to get started, the best thing to do is to search on Google for WAAPI and Python. So you search for that, and one of the link that is important here is the remote procedure call. So first thing to do when we're there is to install the client. So there's a Python library you need to install first. So we'll copy this line. If you're on Windows, if you're on Mac, it's the other line. So I'm going to use the terminal in VS Code and paste it over here. So I already installed it, so it was fast, but if you did not, it may take a few seconds. Next thing, I'm going to copy this Python example and over here. So let's make it bigger a bit. Okay, so let's clean this a bit just so we can understand what's going on. So remove. I'll remove most of the example because we want to keep it simple. So what we have here is a simple Python script in which we import with WAAPI client. We also use pprint for debugging, and then we create a new client, WAAPI client, and then we call a function getInfo. So the client in WAAPI has only 3 functions, I think. There's a call, there's also a subscribe and unsubscribe. That's the thing you can do with the client. And then when you use call, you need to specify which function you call. In this case, we're calling getInfo. So this is going to connect to Wwise and get information about the Wwise process that is running. So I'm going to run this. So it runs, and so we see here it returned information, and we have the version of Wwise, for example, that is currently running. And let's go to Wwise here just to see what's happening. So in the toolbar, there's this area here, which is the log area. So this is clickable. I'm going to bring it to the screen here. What's interesting is the WAAPI tab here. So if it's the first time you go to this log, there's one thing you need to do is go to the settings and go to the WAAPI tab and then select all the things here and make sure they are enabled. So this is going to make sure that everything that happens with WAAPI is being logged here. So we're going to clear it and then run the script again just to see what's happening. So we see we have the call getInfo, and we have the arguments and the result of the call. So this is pretty useful for debugging WAAPI. So keep that in mind. So let's. So now we have a script that is working. We're able to call a function. It works. So let's try something else. So there's the get project info, which is a new function in 22 also. It returns information about the project that is open. So we have the Wwise adventure game open, and we have a lot of information about the project here. But this is not what the demo is about. So what we want to show today is more about object.set. So yes, so ak.wwise.core.object.set. So new function, and as opposed to the other functions we called earlier, this one takes arguments. So we will define arguments in the script. So object.set, it takes a list of things to do on objects. So, well, let's say we start with this. Well, let's say we create a new sound in our project. We call it my sound here. And I'm going to right-click the sound. But before I right-click, I'm going to hold the Shift key, and I'm going to use copy path to clipboard. And over here, I'm going to specify a list of operations. So I'm declaring an array. Whoops, an array, and the first item in the array is an operation to apply, and we need to specify on which object the operation is going to be applied. So I'm going to paste the path that we have from Wwise and escape all the backslash character because we're in Python. So that's the object that we are working on, and maybe let's try to rename the object. That's something we could do. So I'm going to put that here, general settings. Okay, so after that we specify a name, and it's currently called my sound, so let's call it your sound. See? And what? Oh, I did something wrong. So object.set, it takes actually a list of objects, and this list is defined with objects. So we specify which objects, and then we specify the list of objects. So that's better. Okay. So we only have one object in this case, and it's the my object. So I'm going to run this, and yeah, it works. Now we have your sound here was renamed. So I'm going to press undo. Let's try to do something else. So let's try to change the volume. So the name is part of the name field that we used here is part of the object system in Wwise, as opposed to properties. Properties are contextual to objects. So different objects in Wwise will have different properties. And the volume is actually a property of an object. And if I want to set the volume, I'm not going to pass a string, but I'm going to pass a number like minus 18, for example. So this should set the volume of the object. I'm going to run the script, and you see the volume here is now minus 18. I just pressed undo, but let's try to also set the pitch to 200. And yeah, let's try this. Run this. Now we have our two properties that are set. Next thing I'm going to do is I'm going to modify the project. So let's say I have a low pass of 22 here, and I want to set new pitch and new volume. What happens if I run it? So you see the object.set, it just keeps the object there. It does not change anything else that what is specified. So low pass filter remains there. Next thing we could try. So that's set different thing. Oh, let's try to set the output bus maybe, because that's something that is common. So at the moment it's the master bus. So let's set this object on. Let's set the bus to world. Let's see. So I'm going to right click here, world, and copy path to clipboard. And I'm going to use to say upper bus like this. And then I can specify a path. That's one way to do it, but there's other ways. So in WAAPI, we can refer to objects by path, like here, we have a path. I could also refer to objects by GUID. An example would be, well, right-click, copy GUID to clipboard. It's going, and then we can use the GUID here. This is a more direct way to access the object, but we have actually no idea what this object is when we read the script. So the path is actually useful for documentation. of the script. But for buses, the buses, they have something special in Wwise, is they have a unique name across the project. You cannot have two buses with the same name, even if they are at different place in the bus hierarchy. So they are unique across the project. So we actually don't need to specify the path because the name is unique. But the thing is, you could have an event called world, or maybe an effect called world. So how does Wwise make the difference between the different worlds? So we still need to specify that it's a bus. So bus world. So let's try this. Run it, and then you see here it's now going to the world bus. Works. So, let's try to maybe set the notes. At the moment, there's no notes, so I'm going to set the notes. So the notes is a bit like the name part of the system, so there's no at the beginning. So I'm going to say hello in the notes and run this, and we see hello in the notes. Okay, so now we're able to set things on objects. And there's actually a lot of things we can set on objects, and let's take a look at the documentation about that. So if you look on Google for Wwise object reference, you'll find this page. And this page has the list of all different objects in Wwise. There's a lot of them. And there's the sound. You can click here because we're working on a sound. And this page enumerates all the properties you can access with WAAPI. Because sometimes the name might not be so evident. For example, if I want to set the loop property here, the loop is actually called is looping enabled. So I'm going to try it here. So let's open back here Wwise, and so I'm going to use the at since it's a property, and this one is a true-false property. Oops, what did I do? I closed the file by accident. Okay, so let's try this. So it should, in theory, check the loop. Yeah, it works. So we are able to set the loop property. So now we're able to set things on object. That's done. Let's try to create a new object. So instead of having an object here already created, let's try to create a new one. In this case, we'll start with the default work unit because this is our point of start. So I'm going to right-click it, copy path to clipboard again, and on this case, actually, yeah, I'm going to use default work unit, and I'm not going to set a volume on the default work unit because it does not exist, but I'm going to instead set the children of the default work unit. So, and we'll create a new one. So one of the children will have type sound, and let's take everything we had here and move it over here. And our sound also, oops, sorry. Our sound also has a name, and let's call it my sound. Okay, so I think we have something now. So let's summarize what we did. So we specify which object we want to modify. In this case, it's the default work unit, and we are going to set children on it. And the children is a list of objects. Oh, it's missing the. Oh no, it's here. The last, like this. Okay, so I'm going to try this. Let's cross our fingers. So at the moment, default work unit is empty. I'm going to run this, and we have an error. So let's take a look at the errors. So it's a Python error. We have a problem in the syntax. A comma is missing. Okay. So let's try again. Ah, it works. So we have a sound, its name, my sound. It has some notes, volume, pitch, and a bus. Everything is set correctly. Nice. And what we could try create a second sound. So I'm going to copy this here and paste. And the second sound, we'll call it my sound 2 or your sound. Your sound. Okay. So let's. Oh, and this time I'm going to set my low pass filter here because first time I ran the script, was happy with that. I tweaked a few things, and I wanted to run my script again, but this time there's a new sound. So, oh, okay, haha, we have an error. Because what's happening here is we're asking the system to create an object that already exists. And by default, to make sure you don't erase anything in your project, WAAPI actually refuse it. So let's see how to fix that. So right now I'm on the documentation for object set, and right at the bottom of the page, sorry, it's a bit long. Okay, we have on name conflict. So this is an option we specify along with the objects here. Let's specify what to do when there's a conflict in the name of when we create new object. And by default, it's fail. So let's use the merge here because it's probably what we want in this scenario. We want to merge what's already there with what we ask. So let's try to run this. This time it worked. So we have our sound. Your sound was created. My sound still there with my low pass filter edit still there. So we basically merged the definition of objects that we had here with the current project, which is great.
That's awesome. And so in the case where on my sound you've authored that low pass filter manually, so it doesn't when you run the WAAPI script, it doesn't touch that property. If you had specified a low pass filter value that was different than the one you authored manually, the WAAPI script would modify that.
Yes, exactly.
Gotcha. Cool. And is there, maybe this is too far and just keep going, but is there a method to check whether that value is the same as the one that that the script is trying to change it to? Like,
well, we could query it
yeah.
with WAQL, but I did not prepare anything.
That's okay. Keep going. And again, I think I was just proposing other ways to understand that manual authoring and take it into consideration as part of the scripting. You're doing great. Keep rolling.
And actually, in one of the examples that we'll be talking later, we'll be using both WAQL and object set together to make something that makes sense. Because at the moment, the script is just pushing to Wise. It's one direction. So that's an overview of what can be done with object.set. So in summary, we can pretty much set everything, anything, and you can set many of them. And one advantage of using a batch operation like this, well, there's many. One of the advantage is it only creates one undo, so you can undo in Wise, and it's going to undo everything in one operation. The other advantage is it minimizes the overhead of WAAPI, because there's a bit of overhead for the travel between the client and the server. So if we were to set, for example, all these properties and names and notes in different WAAPI calls, it would introduce overhead. That if you're doing it on hundreds and thousands of objects, it could be longer. So this is optimal in terms of usage. Okay, so let's go back to the slides, I think. Okay, so we had the demo of object-set. I think we're ready to talk about the GitHub project. Are we? Okay, so this is the address. So this is my Audiokinetic account, and aka Rodrigue, and the project is called WAAPI Python tools, and there are 6 tools on that GitHub repo. So let's go to it. I already opened it here. So 6 tools in different folders. There's the instructions for installation. Some of the, well, there's 3 tools that were made 3 years ago, so they don't use the new features of WAAPI. And there's the 3 new also tools that were made recently. They use the 22.1 features. That's one thing. And so to get the files, you can either clone the repository, or you can download directly the files. And to install the file, you need to install them to the app data folder. So I'm going to go there. So in app data, oops. So you go to app data, and I think there's also a, do we have instruction for Mac? Actually, we don't have instructions for Mac, but it's some of the tools are working on Mac and some no. So if, okay, so so search for Wise.
There was the other platforms item there. So under the WAAPI client, Windows other platforms. Yeah.
Right. So that's how to run the tool, but the command add-on. So this set of tools is using WAAPI for and Python, exactly like we did for the demo, but it's also using the command add-ons. So command add-ons allow you to add new commands to Wise. Commands are basically just action you can execute inside Wise through menus or keyboard shortcuts. And command add-ons can be installed. Here we have the Mac path here. So search for Wise command add-on, and you will find where to install the command add-ons on Mac. And the Windows path is app data. So I'm here on app data, and there's already a Wise folder here, but you might not have add-ons already created. So you need to create a folder called add-ons with the S, and then you can drop the files from the repo there. So for me, I just git clone the whole repo here. So I have the entire repo here, and I already opened it in VS Code here. That this is what this VS Code instance is about. So we're going to go through the different examples. Oh, and one thing also, once you unzip the add-ons, there's a commands folder here, and that is important. That is actually read on startup by Wise. So when Wise startup, this JSON file is read, and this is the definition of the commands. So well, let's take a look at it. So the command file is has a definition of all the commands that we install in Wise, and each command has a ID, display name, default shortcut, and what's more important here is the program that we start to execute the command. In this case, it's a Python script, so we run Python, and we specify the directory in which the Python script is installed, and then we have arguments. And what's nice with commands in that you can pass Wise things to them. So here I'm passing the ID of a Wise object. So whatever selection you have in your project, you can actually pass the ID as an argument to the program. So and then this program can use it to execute stuff on selection. So we have a bunch of commands here. And if you install the commands like I did, you should be able to see them in the keyboard shortcuts and command dialog. So we see here we have 5 commands here that auto things that are installed, and at the moment only one have shortcut, but you should be able to see them here. If you don't see them, there's something wrong. You might take a look at the log in the general page. Actually, yeah, you should see any error about loading the command file. Okay, so I think we're ready to go through the tools in the repo that we presented 3 years ago. We'll just go a quick demo of them and an overview what they do.
Cool. Before we jump into that, I just wanted to carry this forward from the chat from Mike Patterson, sharing with us how he and his team have been using WAAPI. One thing that he did for the team was to explore using WAAPI in a C++ script to create a small command line program that works as a Wwise command add-on for outputting lists of WAV file paths for animators. Again, just a great application of WAAPI to empower that animation team. Beautiful.
Yeah, it's all about that. Wwise is a big spreadsheet, and there's a lot of data there, and WAAPI allows you to access and manipulate this data and to do plenty of things.
Cool. Thanks for sharing that, Mike, and carry on, Bernard. Nice.
Mm-hmm. So, well, let's start with a simple auto rename container. So that's one of the old example. So classic example of game structure is you have sounds like this, and you need, in this case, it's 3 different frog sounds. So I'm going to right click here and new parent, and it's a random container. Okay. Oh, what's the name of the random container? So probably should reuse some of the naming convention of the files here. So, but this tool is about that. So I'm going to right click the container and say auto rename container. Oh, ta-da! So now the script, it look at the children of the selection, it finds a common part, and it put it in the name here. So just an example of how to automate simple things by accessing the data from about the selection and doing something that makes sense for your game.
That was jaw-droppingly awesome, the way it just took what it knew and automatically renamed that object. Really nice work.
And it makes sense if you're using a naming convention in your project. There's a lot of situation where the name, it should not be chosen. It should be derived from the data that is already there. Okay, that's one example. If you want to take a look at the code, you can do it. I won't do it here. It's not using object.set or WAQL. It's older code, but it's still interesting to look at. Another thing we did a couple of years ago is the text-to-speech. So this one, I'm going to create a sound, and let's call it hello. And we will set some notes here, and I'm going to say in the notes, hello, Damien. Okay. So of course, this sound does not have a WAV file at the moment. It's red. The play button is not even enabled. But maybe I need this sound in my game but I don't have the WAV file. So I'm going to generate a placeholder. So generate text to speech. So ta-da! We have a WAV file now, and I'm going to play it.
Hello, Damien.
Classic text to speech. It's using the text to speech from Windows, not super high tech in terms of what we can do today, but still it's helpful. And it's just a demonstration, and actually any more modern text to speech engine could be used here.
Yeah, and the application of this is, incredible. Imagine, front-loading your dialogue pipeline with text-to-speech in order to give your narrative team a better understanding of how things are timed across gameplay, or how those conversations feel. And again, varying degrees of believability on that text-to-speech, but it's that first step towards giving people the context as we're creating these things, oftentimes from nothing, and speeding up that workflow and automating that workflow with WAAPI is incredible. Yeah, nice one.
Next one is the auto-midi-map. So I have a folder on my desktop. I'm going to drag a folder. So you see it's a folder. I'm going to drag it here. So when you drag a folder over the hierarchy, it asks you what you want to do with the folder. In this case, I want to create a blend container for the folder, and all the sounds inside will become sound SFX. So I'm going to import that. And now we have a blend container with all of our sounds here. So this is for a MIDI setup. It's an instrument. It's a flute instrument. And we have notes that were sampled at different notes. And if I go to the MIDI tab and use the MIDI key map editor, I'm going to move it here. It's a bit scary because I have something like 25 sounds, and nothing is set. It's all zeros, and if I was to send MIDI to it, to the blend container, and it would not work. It would play all the notes together. It's not what I want. But since I'm using a convention for the names here, I wrote a script. So if I say auto-midi-map, oops, take a short moment of time, and everything is set in one operation. So the script is parsing the names, finding the root note of each sound, setting here, and then trying to map it on the keyboard, because we don't have all the notes of the scale here, so we spread the notes with the min and max, and so it took us nothing, and then we have a working MIDI setup.
So it's incredible, and things that you said there about parsing the names, so looking at all the names and pulling out the pieces that could be associated with the different values and key map ranges. Again, you're taking what you know about the files and the naming standard and translating that into properties and setting those properties using WAAPI.
Mm-hmm.
Nice. We got another one from the chat, and thanks for sending these. This is Danny Kogan. Hey, Danny. He started using WAAPI to create huge automated structures in Wwise, and some were really hard to maintain if it hadn't been for WAAPI automating that import process. So smart thinking, smart WAAPI usage, you're really thinking with WAAPI at that point where you're using it as a way to maintain, automate, and get consistency as well, streamlining your processes. So good to have you here with us today, Danny. Thanks.
Mm-hmm. Yeah, here it's really a good example of reducing error and human errors. Because if I was to set this by n, well, at first it would take me an hour probably, and I would probably make an error somewhere. That's for sure. That's
Yeah.
super hard to do, and computer is perfect for that.
Yeah, well, and imagine like this was the flute instrument, but you're setting up a whole orchestra for MIDI, right? You're going to have to do this process over and over, and I bet the time that you spent crafting that script, you know, would pay itself off after you got through the win section, like that repetitive task. And well, cool that it's already in the box for folks who add those command add-ons. So you should, if you're
So
if
maybe
you're working on that, you should definitely be leveraging that.
So maybe an exercise for anyone that want to use that. At the moment, the script does not handle different velocities for sounds. So if you had recorded your sound at different velocities, different intensities, maybe exercise would be to adapt the script to parse those velocities from the names and then use that in the fields here.
Nice. They could even submit that to the Git as a pull request, right?
Yeah, why not?
Cool. That's the community working together.
So now we're at the point where we have 3 new samples, and for those we'll take a bit more time to look at the code and see how it's working. Well, let's start with the auto trim, because last Wise Up on Air, not the last one, but one of the last where we talked about the Wwise, we also did a demo of the auto trim, and we said we would talk more about it, and that's the time where we talk more about it. Auto trim source. So that one is also interesting because it's using different tools to achieve what we want. So an example is the hello text to speech that we generated earlier, or maybe the frog. We have a frog sounds here, and you see we have silence at the beginning and at the end of the files. And sometimes, well, this silence is not welcome because it's taking memory and also taking resource for the game. So you'll be trimming the things here, and then it's taking less memory. But if you have hundreds of sounds like this, might be a bit long and repetitive. So why don't we do it? Why don't we let the computer do it for us? So this is about, so we have auto trim source. I'm going to run it. Does it for me. So the script is going to parse the WAV file and search for silence and according to a specified threshold. And when it finds samples that go over threshold, it actually rollbacks a little bit to find the zero crossing, and then sets the trim here. And same thing for the end, goes from the end and search for samples over a threshold. And then we have also an option to set a fade out. And I'm going to undo. I'm going to select my 3 sounds and again trim source. So now we have our 3 sounds that are trimmed. So it's aware of multiple selection. But maybe for this frog sound, the silence here is important because you might use this silence to synchronize with the animation, for example. So if we trim this, it's not going to behave the same as before. So in this case, we would use the auto trim with initial delay. So it's going to trim it, but any trimmed area will be compensated with the initial delay here. So if you play back this, it's going to be the same as before. So this here silence and then play back the sound. And this is going. This would be actually difficult to do with Wwise, to know exactly what's the time of this trimmed and then fixing the initial delay.
I mean, that's two amazing speed ups for any workflow that's using, you know, I think of dialogue workflows. I think of, you know, multi-sound blend containers where you have all these offsets built into the WAV files that you import, right? You just unlocked what they call topping and tailing for dialogue, you know, at least the simple execution of it, you know, with the right click one and done. And that is the kind of workflow speed up that really hits people right in their workflows. So excellent, excellent illustration.
So let's take a bit of time to look at the code here to see how it works. So this script is using the SciPy library, which has a wave parser built in. And it's also using the argparse library to parse the different arguments. So what I did here is I defined a few arguments. So whether you want the trim or the end to be trimmed or not, and also whether you want a fade at the begin or end, and whether you want to have the initial delay compensation. And there's a threshold also for the begin and the end in decibels. So let's take a look at the sample here, the code. So most of the scripts in this project are starting with similar code. So what they do in general, we receive the ID from Wwise. So as I said earlier, we receive the IDs from the command. So the command is going to pass a list of IDs to the script. So in theory, we should get IDs in the arguments. But the script is smart. If we don't receive any ID from selection from the command line, it actually asks Wwise, "What's your selection?" And then we get the selection from Wwise instead of getting from the command line. So at the end, we have a selection in this variable. And the next thing we're going to do is to find what to set on the objects. So we talked about object set earlier. So here we have our arguments for object set. So same thing as we saw, we have a list of objects. At the beginning, it's empty. We start with nothing. And then we're going to loop the selection. So this script is using WAQL to get the audio source, because you might select a sound or maybe a blend container or a random container. So we have a generic WAQL command that is going to take the selection and then obtain all the audio source that are descendants of the selection. So it's going to work with a work unit or any type of object that has audio source, audio file source. And then from the audio file source, we actually retrieve the original wave file path, which the exact same thing that the viewer mentioned earlier. He was using the file path of the wave files. This is what we do here. And then we'll also retrieve the type ID and also the parent ID. So the WAQL command is passed to the get function, and then we get all this information in a table. So the return is the result of the WAQL query. So I'm going to loop the source objects from the result. And this is where it gets interesting, where we open the WAV file, and then we loop the samples in the WAV file. So we have some code here that is going to find the threshold and zero crossing, And at the end of the loop, we should, well, there's two loops. So the first loop for the begin and the second loop for the end. And at the end of the second loop, we have everything we need to apply the operation. So we're going to, in this case, set some things on the sound and also the source, because the sound, we actually need to set the initial delay on the sound, which is the parent of the source. But we ask for the parent ID of the source, which is the ID of the sound. So, okay, so if we specify no begin, no trim, so if we are looking for a trim at the beginning, we set it here, same thing for end, initial delay on the sound, and then the fade that were specified at command line, and then we add the things in our arguments for the set function. And then we do the loop, all the source, everything selected, and at the end there's only one call to object set. In this case, I'll also use the begin group and end group. So if I go back to Wwise, the undo is called auto trim source. There's a name that makes sense for the user. It's not just object set, because auto trim source is being specified here. And yeah, that's it.
Nice. I love the way that the considerations around how that's presented and just the depth of functionality that you have at your fingertips to be able to modify things as a batch, right? As a process. Nice work.
So let's go to the next one. Auto-create event. Let's take a look at this. So let's do a demo first. So if you're in a team that is using Perforce, for example, and you want to create an event on your sound, it's likely that you don't want to use the default work unit, because the default work unit, well, is going to be, if you use it, well, it means that you need to check out it. And if you check out it, well, you might get conflicts with other people from your team. So you probably don't want to modify the default work unit. So if and that's a problem. So if you use the new event menu here, it's going to go to the default work unit, which is a problem. So maybe we can use WAAPI to fix this. So so now we have our frog sound. It's a random container, and we have a work unit here, Wwise Up on Air. And I know I'm the only one working on that work unit, because that's my responsibility for the week. And I know also that I will be creating events on a work unit with the same name. So let's do that. So let's use our script here. It's called auto-create-event with work units. So I right-click this, and now I go here. Hey, we have a Wwise Up on Air work unit created, and our event name here. So in this way, I'm able to avoid going through the default work unit, and I can also honor the same hierarchy. So if I delete this and let's say I go here and I create a virtual folder, so my work, and I drag it here. So let's try again, auto create events. So this time is going to create also my work as a virtual folder and my event here. So it's trying to replicate the same hierarchy on the event side. So that's one way to work. So maybe you have a different convention for the organization of the work units, so that the script should be a point of start, and you should adapt the script to your convention. So.
And really, the whole thing here is about being able to extend the Wwise authoring and the workflow in the direction of your specific team's dynamic and project structure, because we recognize that while there are a lot of consistencies that we find across projects, every developer is going to move towards these things with their own specificity. And so being able to tailor that using WAAPI in order to supercharge your pipeline for your development style is really at the core of that WAAPI feature.
Mm-hmm. And again, probably you should not invent a name for your event. The name should be derived from the project data that you already have on the audio.
That's smart thinking.
So let's take a look at this script. Okay, so let's start at the bottom. So same thing as the previous script. It's starting with the selection thing, asking Wwise for selection if we don't have one, and then it creates our set arguments. So it's using the objects, and this time it's also using the merge option that we saw in our example earlier. It's looping through selection, and yeah. So if you add any non-playable object, it's going to skip them because we cannot create an event on them. So because I did query, did I query? Yes. So one of the first thing I did actually is I did a query on the here return path ID and is playable, which are three things you can query with WAQL. You can also query the volume, output bus, pitch, but there's plenty of things you can query. But this is the things I needed for the script, so I'm using it here. I'm using it here. So then we take the path of the selection. So in this case, it's a sound or random container. And then we split the path into parts. Because we're going to, in this example, we're trying to replicate the same hierarchy from the audio hierarchy to the event hierarchy. So we need to reuse the same parts. So we split by parts, and then we replace the first one by events, because we don't want to go to the actor mixer, we want to go to the events. And then we remove the last one, and then we add it back, but this time with the play underscore. And this is, again, customizable as your need. And so after this, we have actually a path that makes sense in the event hierarchy. And we ask this function to create the entire hierarchy for it. And let's go to it. So we have create event and work unit. So it receives a path and a target, which is the sound to play for the event. So it's looping through the parts of the path. So it's going to create the object set objects. So we saw earlier that we're able to, with object set, create objects. So it's going to create virtual folders, work unit virtual folders, and then eventually the event. So the first thing it does, it actually starts with the end. It creates the event, and then it adds things on top of it, and then pushes the event down to the JSON content. And at the end, we have the actual JSON object that represents the hierarchy to pass to object set. And the other function is creating a virtual folder. So we saw in the object set example earlier, we were able to create a new sound. So we had type sound and we had the name. Here it's the same thing for a virtual folder, and here we have the work unit version. And for an event, we're creating an event, which is the type, the name, and the children of the event is the action. Because if you recall in Wwise, when you create an event, you could have multiple actions. You could have a play, stop, mute, etc. But in this case, we only have one action. It's a play action. And then the target is specified here. It's the sound, or here maybe a random container is going to be played.
How do you know it's a play action?
Good question. Because each object type in Wwise have a default value. For example, the volume has a default of 0.
Cool.
In this case, the action type is default play, so we don't need to specify.
Perfect.
But if it was stop, you would need to look at the documentation. So let's take a look here. So let's go back to our list of objects and take a look at the action. So action has properties, and one of them is action type. And the documentation tells you which number to use for all the different actions that are possible in Wwise.
Wow. So you could essentially, line up an entire complex event pointing at different objects as part of event actions to basically automate that process of creating an event, all of its actions with its association to the objects that it was controlling.
Yeah, and it wouldn't be difficult also to create, for example, automate the creation of a stop action.
Yeah.
So you could create a play and a stop at the same time with the same script.
Nice.
That would be an exercise to do.
Cool.
So that's the create event. And there's one more script to look at. Is there any question on the chat? Silent.
Everyone's holding up well so far, it seems, but for sure, drop those questions into the chat if you have them. We will take your silence as pure acknowledgement of the power of WAAPI. So, but do drop those questions in if we can help expose other aspects of this that are interesting to you, or shed light on things that we've already talked about.
Okay. So last script is the it's called new-synth-one. So, well, let's demo it before. So I'm going to right-click this work unit and use the new random synth-one x10. So it's going to create 10 instances of synth-one, 10 sounds, and each of them has synth-one for the playback. So, well, maybe we can play them. So it's one. Okay. Random. You never know what's going to go out of it.
That sounds great.
So let's take a look at this. So as I mentioned at the beginning of the presentation, when I talked about object set and what it was doing, so I mentioned I was able to create source plugins, and this is what this is doing. So it's using object set to create source plugin, in this case synth-one. It's also able to create RTPCs, and we see here we have a synth-one with different RTPCs, and this script is actually creating random modulators. So we're using the time modulation, we have time execution, we have envelopes and LFOs, and if I go here, we even have other RTPCs on the sounds. We have RTPCs on the sound and RTPCs on the source plugin. And same thing for, well, if I go here, go through the different, you see each of those objects that were generated have different modulation, randomized. So that's why every time we play, well, there's a couple of things. So all these sounds are going to be different, but every time we play a single sound, it's going to be potentially slightly different because we're using randomization, for example, on certain arguments, certain RTPCs.
Right, and I know you're going to step us through some of this, but is that randomization truly random, or are you doing some constraints to, I don't know, keep it in the usable range?
Well, it's up to the script to define.
Great.
So the script, when it defines a random, it defines a range, acceptable range, because maybe if the range is too high, it's not going to. For example, the volume, we may not want a randomization that would make the volume minus 80.
Yeah, exactly.
Or a low pass that is too high because it would completely remove all the frequencies.
Great. And so while you can take these randomly generated things in Wwise and further modify them, also back at the script for this, you also have control over some of those constraints for how random these properties are when they're generated.
Yeah. So this is basically an example of object set with using the new features in 22. But this script could be adapted maybe to generate sounds that are a bit like SFXR, the project that you can find on the web, where you have preset of constraints. Each property can be this range, and this range is going to generate this type of sound, like a jump sound or so.
Yeah, and the difference there, of course, with SFXR, it's like generates wave files at the end of that process. You consume those wave files into Wwise, and now you're working with waves. Whereas what you're doing here is you have that same kind of joyful randomization that SFXR brings, and yet it's using synth-one. It's all at runtime. There's no media. There's no wave file reference, and so you're just using what you have at runtime to make some cool sounds.
Mm-hmm. Yeah, and that's the beauty of Wwise. Then you can add your own game parameter to modulate those sounds with game variables, and that's where the sound become dynamic and it is brought to life.
Yeah, nice.
So let's take a look at the code for this one. So this is the biggest script. So yeah, so it's similar a bit to the event script where we were able to create event. This script is going to create also blocks of JSON for the different objects that we need. For example, here, this is the function that it creates ADSR. So we specify which property we want the ADSR, and then we specify the value for ADSR. And then, as I said, we will also specify a min and max on which the ADSR is going to be applied, and also an option to stop the sound at the end. And it's using the same thing as we saw in the example. So properties, we have we also create new objects. For instance, here we are creating a control input. So here it's the envelope, and we also set objects properties. We also have a curve, the ability to set curves on the RTPC, so we can specify points here. So this is ADSR. We have similar function for LFO. We create again RTPC, but this time it's their control input is a LFO, and it also has a curve with properties. And so the script, there's two types of randomization. So we saw some random modulation happening in the RTPCs here. For example, rand. So this is actually using the LFO object. There's a type of waveform called random. So a bit like sine, triangle, square. The random is going to be evaluated every time once per playback. So it's going to pick a value between this and this and use it for the playback. So, but this is one type of randomization, and the other type of randomization is at the execution of the script. For example, the depth of the LFO is selected at when we run the script. So it's baked in the property. Same thing for the waveform. Here we have the random modulation I was talking about. So it's a LFO with the specific waveform. So the waveform number 5 is the random one. And this could be found in the documentation, in the list of properties for a modulator. And then we...
Oh yeah, this is the one I was thinking of, is the random points. So you've got your RTPC curve, right?
Yep.
How does it know how many points to put on that curve? Do you have control over, whether it uses 1, 10, or 20?
Yeah, so the random modulator here is LFO, is a LFO. And LFOs, they only have 2 points in the curve, which are the min and max. But if I take, for example, the time one, maybe we can find one that is more. This one, yeah.
That one's cool.
So we have here a random curve. So the algorithm is going to pick a random number of points and then randomize the point over the range and over time.
Gotcha. So part of that setting the points is choosing a random number of points and then randomizing the value of each of those points along that RTPC curve.
Yeah.
Nice.
So that's it. Random points. So this one is going to first pick 2 points for the extremity and then insert point in the middle.
Yeah. Nice one.
And then random curve. And then we also have a function that is going to pick randomly one of the different modulation that's possible. So if I just call for a modulation, it's going to pick one of the random time curve, random value, LFO, or ADSR. And then we have a function to create a sound. That's a bit similar to what we did again in the first example. So type sound, we're creating a new sound with a name, and then we use here some code to name it with a unique name, and then we specify children to the sound. In this case, it's a source plugin, and we define properties and RTPCs again, and this is where we call those random modulation on the different parameters. So this script, I have personally chosen some properties to randomize, but anything could be randomized. It's easy to add any code here to modulate anything. Yeah, and at the end we have the main function, which is going to generate a certain number of sound at the location that you specify, which is taken from the selection. And there's a problem here. It's called auto trim source. Should be called generate new-synth-one.
Perfect.
Yes.
Nice. Real-time
Yeah.
coding. Here we are.
So that
Excellent.
goes over the different scripts that we have on the repo, and yeah, they're there to look at for inspiration.
Yeah, well, I can imagine just jumping in and starting to, copy and paste parts of that in order to get closer to what I might need in my own pipeline, because there's already a ton of examples in there. And as you've shown, it's all online, it's all in the documentation, and that's one way to approach finding what you need. And with these samples, this resource, you can also just start leveraging what's already in place to put it into a shape that helps speed up your workflow. Nice.
Mm-hmm.
Cool. Feel like, do we need to go back to the slides? Did we get to the end?
Do we have more things in the slides? No, that was the last slide.
Perfect.
So maybe I can put that on screen again.
Great. Excellent. Well done, Bernard. Great job surfacing how WAAPI can be a part of your pipeline, speeding up workflows and optimizing your project. I feel like there's one missing thing on that slide deck, and it's the holiday sweater show off, because we both coordinated our outfits today. So I think it's time, right?
It's time.
We didn't really talk about it or how we were going to do it, but I'm backing up to get full screen on this holiday sweater. I might even use the magic of this to lower my desk. Yeah. Okay. Success. Well, that rounds up another fantastic Wise Up on Air. And yeah, this is, it's always great to have you. You bring so much information and experience to the live stream for folks to learn from. Mike wants to know if we have a WAAPI script that syncs up our sweatshirts every day. Nice. I see what you did there. But again, thank you for bringing all this knowledge to the community. And folks out there who are just jumping in, let us know how it goes. Hit us with some feedback. Find us on the Wise Community Q&A at audiokinetic.com. And yeah, let us know how you extend your workflows with WAAPI and WAQL. We're excited for folks to dig in and keep working. So dig it. All right.
Pleasure.
Thanks so much, Bernard. We'll see you soon.
Bye.
All right. Take care, everyone.